For 2.1s, we are going to start talking about a different type of number now. So we've been talking about integers, which are whole numbers. So we are going to move on and talk about the next level of numbers. So these are called rational numbers. So a rational number is any number that can be written in the form of A over B. So as a fraction, A over B, and A and B have to be integers. So they have to be whole numbers, so positive or negative, but they have to be whole. So counting numbers, 1s, 2s, 3s, and so on. So we can't have like 7.2 as A. That's not a whole number. Whole numbers and B cannot equal 0. Because if I made B equal 0, so if I had the number 7 for A and I put B as 0, 7 divided by 0, that equals 0. And 0 is not a rational number. It's kind of its own special thing. So here are some examples of rational numbers. 0.35. So you might be wondering, well, Mrs. Richards just said it's a fraction, right? Decimals and fractions are the same thing. 35 hundredths, I can write this as a fraction, 35 out of 100. These are both whole numbers. B is not 0. 35 hundredths, that is a rational number. So decimals are rational numbers. It's an example. 4 out of 5, 4/5. Whole number, integer, integer. So 4 over 5, or I could call that 0.8 is a rational number. The whole number 6 is a rational number because I can put 6 over 1. 6 divided by 1 is 6. But I could make it a fraction because that's not 0. It's a fraction. A over B, 6 over 1, still a rational number. I could say that 8.0472 is a rational number. I could have 8 wholes and 472. So let's see, there's tenths, hundredths, thousands, 10 thousands. 1, 2, 3, 4. So 472 10,000s. That is a very tiny, tiny number, but that is a rational number because I can write it as a fraction. So if you can write it as a fraction, it is a rational number. And they're opposites. So negatives are included. So now we're talking whole numbers. We're talking decimals. We're talking fractions, positive and negative. So we're going to start looking at some trickier numbers than just 1s, 2s, 3s. We're going to go into these fractions and decimals that we call rational numbers to compare and order and put them on number lines. So here is this number line, and we can break it down. So here's 0. And then we can see here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces to make a whole. So, right, it's just broken down into these 10 pieces. This is just kind of a magnified view of what this looks like. And in this, I could even break it down farther, and there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. This would be 0.01, 0.02. All the way to get to 0.01. Here's 0.11, 0.12, 13, 14, 15, 16, 17, 18, 19, 20. Because 0.2 and 0.20 are equal. So if you remember that from 4th and 5th grade, these are the same. So we can take this and we can break it down into teeny tiny pieces or anything in between there. So if I'm looking at 2.6, negative 2.6, so this is a rational number because I could write it as negative 2 and 6 out of, this is the 10th place, 6 out of 10. And I want to mark that. So I'm going over. So here I can see 1, -1, -2. Here's -2.5. Here's -2.6. So go ahead and mark -2.6 on your number line. And the question asks us -2.6 is to the blank of 0. So we had to go this direction, which is to the left of 0 to get there. And you can ignore that little guy. So that is to the left of 0. So that means it's going to be smaller than anything that is this way. So even if we were comparing it to -2.5, it would be less than -2.5. If I compared it to anything this way to the left, if I compared it to -2.7, then -2.6 would be bigger because it's more to the right. Right is bigger, left is smaller. So we follow all the same rules of our number lines with whole numbers. Bigger, smaller, bigger, smaller. Right is bigger, left is smaller, up is bigger, down is smaller. We're just adding in fractions and decimals that we are doing this with.